Hey, we are done with rational functions. So we're going to move on to statistics. We're going to start statistics talking about center, shape, and spread. Now, we're going to remind you how you find these measures, but that's not our focus because I'm going to teach you how to do all of this on a calculator. Our focus is more the bigger picture right now. Okay, so starting with the bigger picture. We divide data distributions into different categories of center, shape, and spread. All three of these describe the distribution of the data, which is how it's spread across the graph. The center. The center is usually what we consider to be the center or median of the data. If you look at this histogram, if you remember, or table anyway, you'll notice that it says donuts eaten. You'll notice that the majority of people ate 5 donuts. Okay, so there were just as many below it as there were above it. This is saying, if you want to remember your graphs, this is saying that one person ate 3 donuts, 2 people ate 4 donuts, and 3 people ate 5 donuts, 2 more people ate 6, and 1 more person ate 7. Okay, but that means the exact center number a person would have eaten was 5. Okay, so measures of central tendency. This is where we include the mean, median, and mode. Reviewing these, because you guys have spent years and years finding these, the median is always found by placing the numbers in the data set in numerical order, finding the middle number. If there's an even number of terms in the data set, we always average the middle two. Okay, just recapping, I'm not going to have you actually finding it today. Mean is the average. So we add up all the terms in the data set and divide by the number of terms. Okay, mode was the number that occurred the most often. There can be more than one mode for a data set, or there can be no mode at all if every number only occurs once or if every number occurs twice. Okay, so those are what we consider central tendency. They describe where the center of our data falls. Now, because not every distribution is perfectly distributed like this, where it makes a nice curve and the center is exactly in the middle, we have something we talk about called shape. Okay, so there are 4 ways we can describe a graph shape. First off, we can say it's symmetric if the left and right sides of the graph are mirror images of each other. So this one up here was symmetric. This one down here is symmetric. It's the same graph, actually. Haha. Okay. Now, most data does not fall exactly symmetric, and so sometimes we describe something as almost symmetric, nearly symmetric, if it looks that way. Okay. The other thing we can do is sometimes the graph looks like a roller coaster and has a number of peaks. A peak is an area where the graph is higher than the surrounding areas. So if the graph has only one peak, then we describe it as a unimodal distribution. So like this one here is a unimodal symmetric distribution because it has one peak and it's the exact same on the left and the right of that peak. Now, if a peak only occurs at the center of the graph, we also call that bell shape. See my pretty bell? Okay, so that's bell shape. That's what we call a normal distribution. Now, it can also have 2 peaks. So it goes up, it comes back down, goes up, comes back down. This is what we call bimodal, okay? All right, the next thing that can happen with our data, and like I said, we go with whatever one of these is closest when we're describing it. It might not always be perfectly symmetric, but we can describe them as nearly symmetric. It might not always be perfectly skewed or perfectly bimodal, but we're gonna go with the best descriptor. So if we have more data on one side rather than the other side, we call it skewed, okay? It can be either skewed left or skewed right. So when we do skewed left, okay, you're gonna notice that there's like a tail that's coming off to the left. That's how I know it's skewed left. It's wherever the tail's going. Over here, the tail is coming off to the right, and so we say that's skewed right. Now the weird part about it is even though I'm calling it skewed right because the tail's coming off to the right, there's actually more data on the left side, which means that your average is going to be closer to the left, and so is your median, okay? Now, the last option is if the data is completely flat across the top, we call it uniform. Like I said, nothing is ever perfect if you're using real data, so we go with the best descriptor. So when I look at this one, it's not perfectly uniform. It's not forming a straight line across here, but it is pretty uniform. And so I would describe this as mostly uniform. All right, so those are the 4 different ways that we can describe spread. Okay, we can describe it as symmetric, we can describe it as by the number of peaks, we can describe it by the skew or uniform. Okay, the last thing we're going to talk about is spread. And spread becomes very important in this. Okay, so a measure of spread is also called a measure of dispersion, and that's used to describe the variability in the data set. Spread talks about how far apart the data in the set is. Okay, I can have a set of data that has a median of 4, and every number can be 4, or I can have a set of data that has a median of 4, and some of the numbers could be up in the millions. Okay, so we want to make sure that we have a way to talk about how those data sets are different, and that's where spread comes in. Examples of measure of spread are range and the interquartile range, or IQR. Now, I know this has been a while. You find the range by taking the max minus the min, and we find the interquartile range by taking the third quartile minus the first quartile. Like I said, it is not so important to me that you can come up with those quartiles. I'm actually going to teach you how to do this all on the calculator. For today, I want us to focus on how different spreads affect the mean and the median and what different things do to the data. We're going to do a Desmos to kind of go over these things. And then later, we'll talk about how we can use the calculator to get some of these measures. Thanks. Bye.